Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is Asteroid collision. So we are given an array asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning right, negative meaning left. So what the problem statement is saying is there will be a array asteroids given, and each value in this array will be either positive or negative. Positive value indicates that the asteroid is going in right direction, and the negative value indicates that the asteroid is going in left direction. I hope it's clear. Each asteroid moves to the same speed. So speed of all these asteroids will be same speed. Find out the state of the asteroids after all collisions. We have to find out how will the resulting asteroids array look like. After collisions. And the rules for collisions are given. If let's say two asteroids meet, and this, let's say this is one asteroid and this is another. Now the asteroid with the larger size will survive and this will be destroyed. Smaller will be destroyed and larger will survive. If two asteroids meet, the smaller one will explode. If both are of the same size, both will explode. So it will be a case, suppose there are two asteroids of same size, then they will both explode. Two asteroids moving in the same direction never meet. So if asteroid 1, say A1 is moving in a right direction and another is moving, A2 is moving in right direction, so they will never meet since they are moving at the same speed. Also it has to be noted that the direction can also be like this, left and left. So left and left and right will never meet. So these are the rules for asteroid collisions, and we have to return the resultant array after all these collisions have taken place. Now let's move towards the constraint part. The length of the asteroids array is given of order 10 raised to power 4, and the values of the asteroids are given between -1000 to 1000. So none of the asteroids is having zero mass or zero value. Okay. Now in problems like this, what happens is, let's say this is the base where asteroids will be hitting. Let's call it moon surface, moon base, and say asteroids are coming. There are some asteroids that have been piled up. They survived the crash, and let's say asteroid A1 is coming. Let me quickly change the color. Let's say this asteroid A1 is coming in this direction. Then the asteroid which is coming will either be destroyed or survives. Any asteroid hitting the moon base will survive. It will not go beyond the moon base. This moon base is not given in problem. This is just a hypothetical construct to make you understand the problem in an easier way. For example, let's say initially moon base was empty. So there are no asteroids, and there is asteroid coming with -100 value. So this -100 will stay. Since there are no asteroids on the moon base for collision, there should be asteroids on moon base. Asteroids should be on moon base for collision with incoming ones. So I hope till now it's clear. Now if you consider this asteroid, whether it survives or it will be destroyed depends upon what are the values of asteroids here. Values of asteroids on moon base and their direction of movements. Also, it will also depend upon, let's say if this A1 asteroid survives, but its continued survival will be subjected to what asteroid values will be coming after it. So survival of any asteroid will depend upon values and signs of asteroids before and after it. So in this kind of situation where there seems to be no other way other than to follow the rules and just go for a simulation. Going for a simulation with following the rules will be a more intuitive answer than any another answer you may come up with. So we'll just follow the rules, and since we are following the rules in a single traversal, the time complexity will be of n. N is the input size of asteroids array, and since the input size is of 10 raised to power order of 10 raised to power 4, it will be accepted. Those of you who do not know what is the relation of time complexity of accepted solution with input size, I will provide a link for it. So what we will be doing a simulation in a single traversal. Now you may ask, how I will be keeping track of asteroids that are present and their signs on the moon surface. So we'll consider moon surface a stack, and depending upon what values are on stack and their signs. Let me quickly change the color. This is moon surface. What values are on stack and their signs for a particular incoming asteroids. With a particular sign, we will decide whether it survives or it will be destroyed. So, survival and destruction of an asteroid currently for a single instance till it hits the moon surface, we are not considering upcoming asteroids after current asteroid, current incoming asteroid on moon surface, or say moon surface or moon base, whichever you may like. So we are only considering at this point up to this asteroid. Whether it survive or will be destroyed depends upon its sign, its value, and the values and signs of asteroids on moon base. Let me quickly take an example so that you will be able to understand well. So let's take an example. Let's take the first example itself. Let's say this is the moon base. Firstly, since the moon base is empty, the asteroid, let's call this A1, A2, A3. Let me change the color. So let's say the asteroids will be coming in this order. So first A1 will be coming. Since the moon base is empty, A1 will survive. Now A1 is 5 plus 5. Now 10 is coming. Since it's plus 10 and the value on the top of the moon surface is A1 and direction are same. By direction I mean signs, whether it's negative or positive. So signs are same, so it will also survive and it will be added on the moon base. Now this asteroid will be coming. So the topmost value is 10 and its direction is this way, right side, and the incoming value is going this way. So they are of opposite signs or opposite directions, so they will collide. Collision, pardon me if my spelling is incorrect. Collision is going to happen if the signs are of opposite direction. So according to the rules, if the smaller size collides with the larger size, then the smaller size will die. Here the size represents only the value, not the sign. So value is 5 and another's value is 10. So 10 will survive, 5 will be destroyed. So here 5 will be destroyed, so we will not be adding it to the moon surface. So 5 will not be added to the moon surface, and only two asteroids will be there, 5 and 10. Also, there might be a case, for example, let's say this is the moon surface, and two asteroids are coming, one with -2 and one with -1. So firstly we will consider till here. This is the current asteroid under consideration, current asteroid under consideration, and this is the current moon surface. This is the moon base, and asteroids are coming this way. So its direction is positive, what is on the base top, moon base top, and its direction is negative. They are of equal sizes, so both of them will be destroyed. So moon base is now +1, and now we'll be considering another asteroid and not beyond that, and now the top is +1 and the incoming is -1, so they are of opposite signs and of same size, so both of them will be destroyed and the moon base will remain empty. So you will return a empty result, or say array or vector, whichever you are asked to return. It depends upon language to language. So this would be the case. So this is the approach for the problem. Now let's move towards the coding part. So what we have done is, we have considered a moon base as a stack. Why we have considered a stack? Because till now we are considering whatever is on the top of moon base and the current incoming value, not the values beyond it. Beyond it we are not considered about what is the beyond current asteroid under consideration. So these two are only under consideration, this top of moon base and current asteroid under consideration, or incoming asteroid. So we'll be doing traversal of asteroid array in a left to right fashion. What we'll be doing is, if the moon base is empty, there is no asteroid on the moon base, then we simply be adding the asteroid on the moon base. If that's not the case and there are asteroids present on moon base, then we will consider moon base as a stack. So what we will check is, till the moon base is not empty and the current asteroid's direction is negative, it means that now for two signs, positive and negative, there will be positive and negative, there will be 4 scenarios. Either it will be positive positive, negative negative, or negative positive, or it will be positive negative. So if you what positive means, here all the positives, that means this direction, and all the negative means this direction. It's positive, So its direction will be this. So you may see the same direction ones, the one with the same direction, they will not collide, it will not collide, it will not collide. Also these are in opposite directions, but one is going to right hand side and another is going to left hand side. So there is no chance of collision. Only collision will happen when one is coming this way and another is coming this way. So this is the only check that you will be making. The moon base should be having a positive and the incoming should be having a incoming asteroid. The asteroid on moon base should be having a positive sign and incoming asteroid should be having a negative sign for collision to happen. So this is what we are checking. If the incoming or the current asteroid under consideration, this is the incoming asteroid. If the incoming asteroid is of negative sign and the asteroid on the top of the moon base, it would not be zero. So you can remove the zero equality, since it's mentioned that none of the asteroids is having zero value in the constraints. So you can remove it. It will not change the result of the program. So that's pretty much it. And then we are checking what are their values, so we can make a decision which one will survive. And we are taking absolute of their values, since we are only considering about the magnitude of their values. So accordingly we will be popping the moon base, or will, if not the case, for example, let's say moon base is having a larger positive value, and let's say it's having plus 10 and minus 5 is coming. So their magnitudes are 5 and 10. So this one will always survive. And what will make the moon base to pop is that this value, positive values, magnitude should be lesser than the incoming values magnitude. Incoming value magnitude. So till then we will keep popping the moon base, or the moon base becomes empty, we will stop. Now we will check if the moon base have become empty. If that's the case, we will simply add the new incoming asteroids index to the moon base. One thing I forgot to mention is moon base will be storing the indices of asteroids. So if that's not the case, and if the current asteroids value, the current asteroids value is negative and the moon base is positive, so there would be two scenarios in this case. Either the moon base is of smaller size, and if it's of smaller size, then the current asteroid or the incoming asteroid will be destroyed. And if it's of the same size as of the moon base, both of them will be destroyed. So we'll again pop the moon base. And there might be a case that this condition is not satisfied, this above condition, then we simply put the asteroid on the moon base. So the condition I am talking about is like this. Let's say moon base is having -5 and incoming asteroid Let me quickly change the color. Let's say this is the moon base, it is having -5, and incoming asteroid is +10. So it will be in this direction, and the current top of moon base will be in this direction. So we'll simply add +10 to this. There will not be any collision. So the directions here are like this. This is moon base, this is incoming. So in that case we will simply be adding the index. So at last what we will be doing is, so the moon base will be representing the resultant array in a let's say this is the top of the moon base. So we have as we keep upon popping the moon base and storing it in array, the current array, result array will be of opposite order, since stack stores in last in first out way. So we will reverse the resultant list or vector, whichever the question is asking you to return, and we will simply return it. So that wraps up the today's Leetcode daily challenge. Solution for today's Leetcode daily challenge. Thank you for watching. You may subscribe to my channel for more such content, and you may also follow the LinkedIn page that we have created for the channel. So you will be notified for the upcoming contents like this, and further notifications about upcoming problem solving content. Thank you very much for watching. Thanks.